All right, let's continue here. We started with MOSFET. We started looking at the layout of a MOSFET. All right, and then we said that you're all familiar with this. There are certain aspects that we want to pay attention to. Number one, there is some kind of diffusion, the source and drain regions. All right, so we started talking about the layout, the source and drain diffusion regions. When they are being fabricated, they tend to extend underneath the gate. All right, they tend to encroach into the gate, under the gate region. That brings a lot of capacitance. For one thing, that reduces the effective length of the transistor. All right, so if I have, let's say, if I call this length, this is how I wanted my. All right, we have to bear with it sometimes. So let's say I wanted my source and drain regions to be having a length of L. All right, but because of lateral diffusion, because during the fabrication process the source and drain regions encroach into the underneath the gate area, because of that we have an effective length that is smaller than what is called L drawn or L designed for. Okay, so, and that also brings us some capacitances, overlap capacitances between the gate and drain, overlap capacitance between the source and drain. All right, so that's something we have to pay attention to. This is the structure of a MOSFET, fundamentally a sandwich using NMOS region, NMOS sandwich. All right, what happens if I want to fabricate a PMOS on a P substrate? I know how to fabricate a NMOS, right, on a P substrate. I have NMOS. I have two highly doped regions for my source and drain, right? This is my gate, NMOS. What if I want to fabricate PMOS on the same chip? How do I do PMOS on the same chip? Create a well. Okay, so almost like create a local substrate. This is called N well. All right, on the P substrate, create a little region to isolate my PMOS that I want to fabricate. Okay, so in that I can have my P plus regions and then fabricate my PMOS transistor as if I were fabricating it on N substrate. Okay.
How do you extract the P-type dopant from the N subwell, the NMOS?
We don't have to extract it. We just do it on top of that. Okay. So your question was, how do we isolate the substrate and clear this of the P substrate, P dopant, and then on top of it? That was your question, right?
Yes.
We don't do it. We just on top of it. Or typically, yeah, that's what we do. N substrate to create the N well. Now, what problem could arise from here? What could be a problem that could arise from here? All right. Let's say I want to fabricate another NMOS. Okay, what do? I use the same substrate, right? I use the same substrate as the body for this guy. All right. So if you notice, a bunch of different NMOS transistors, all right, are sharing the same substrate. All right, they're sharing the same bulk. While a PMOS, each PMOS can be fabricated in its own well. All right. So what happens is, when you see something like this, the problem is when you see a bunch of NMOS transistors sharing the same substrate. All right. So the bulk terminal, the substrate that's representing the bulk terminal that's representing the substrate is common for both of them. All right. Now you cannot do this